Hi everyone, welcome to section 4.3. We're going to look at how to model with quadratics, which basically means how can we come up with equations that represent real life situations, or as close to real life as we can manage in our class. And let's start off relatively simple. Let's say I have these 3 points, 0, 0, -1, -2, and 1, 6, and all three of these points are on a parabola. What is the quadratic equation for that parabola that uses all these 3 points? Okay, what this means is that when x is 0, y is 0. When x is -1, y is -2. And when x is 1, y is 6. So we have 3 different relationships of x and y. What we don't know is a, b, and c. So what we're going to do is we are going to plug all 3 of these into our standard form and then solve 3 equations in 3 variables, which we know how to do, to get our A, B, and C. Let's start off with 0, 0. When x is 0, y is 0. I think this is going to make this one really easy. If y is 0 and I make x 0, this is 0 plus 0 plus c. Well, there we go. So now I know c is 0. I already know one of my letters, right? Let's do the other 2. When x is -1, y is -2. So put that in the equation. Make y -2. -2 is equal to when x is -1. So -1 squared is 1. So this is just 1a. And this is -1b minus b plus c. And we already know c is 0, don't we? But we already know c is 0. Oh, let's make it easy on ourselves. Let's just put plus 0, or no, let's just do that. Okay, now let's do the third one. When x is 1, y is 6. So we'll make 6, change the y to 6, each of our x's to 1, so it's 1a plus b. And now I need to solve for my a and b. And look right here, if I add them together, my b's will disappear, won't they? So we can use elimination immediately. Let's add them together. I get 4 equals 2a, which means a is 2. Ha-ha! So a equals 2. And if a equals 2, then I can just plug that into either one of these equations to get b. And b would need to be 4, wouldn't it? Because 2 plus 4 would be 6. So b equals 4. Let's see if that works. 2 minus 4 would be -2, so it does. So now I have my a, my b, and my c, and I plug that in here for my equation. So y equals, my a is 2, so it's 2x squared. My b is 4 plus 4x, and my c is 0, so I'm done. Let's see if you got that. Go ahead and you try one now. Pause the video, and if I have, and we got another 0, 0, so that's going to make this one easy. What would be the equation of the quadratic that has these 3 ordered pair solutions? 0, 0, 1, -2, -1, -4. Work that out, and then go back and I'll walk through it and we'll see how you did. Okay, so when you plugged them in, you should have got 0 equals c, and this is -2 equals 1a plus b, and then c is 0. And this one, y is -4 when a is -1, but that's squared, so that's positive a, and that's -b. This is just like the last one. This is nice. So we can add them together and eliminate the a's. We get -6 equals 2a. So a is -3. And if a is -3, then it looks like b is 1. b is 1. So our equation is y equals -3x squared plus x. And that's it. How did you do? So another thing that we're going to be able to do is to compare different quadratics. For instance, if you're in a science class and you created your own rockets, and we flew our own rockets that you made themselves, and you wanted to compare their flight. Now, a flight of a rocket is in the form of a quadratic. So if I have this equation that represents the flight of one rocket, and then I have a graph, a picture of a graph of the second one, would I be able to answer which one flew higher? And hopefully I would. So this is the example that's in your book. So without my drawing the graph, I'm going to refer to the book to see how high, where's the vertex, how high did rocket 2 fly? So I'm going to look at the graph to see that. It looks like it's about 580 feet, 575, something like that. So I'll say it's about 580, all right, is rocket 2. Now to find the height of rocket 1, I need to find the vertex. So I'm going to go back to what I learned last section, the negative b over 2a, and plug that in to see what my y of my vertex is. That'll tell me how high the rocket flew. So negative b is negative 150 over 2 times negative 16, or negative 32, and that will give me my axis of symmetry, or my x of my vertex. And I get 4.7. So my x is 4.7. Now to find the height, I make, or I'm sorry, my t, I plug that in for my t to find my h, which is my corresponding y. So I square 4.7, multiply that times negative 16, plus 150 times 4.7, plus 1, and that gives me my height. Use your calculator to do this, and then find your height. So when I do that, I got 352.6 feet is the height of rocket number 1. This is 1. Okay, I should say that. This is 1. So now which rocket flew higher? By looking at the graph and looking at the vertex, you should be able to see right away that rocket 2 flew higher. Okay? Now, your lesson check question. You're going to have to refer to the graph in your book in order to answer it. Is which one flew longer? Which one was in the air for the greatest amount of time? Now we'll give you a hint. The x-axis is time for t. The y-axis is h for height. All right, so you answer that question for me. Was it rocket 1 or rocket 2 for your lesson check for tomorrow, and you'll be good to go. Okay, the last thing that I want to do is show you in this section how you can generate a quadratic equation using your graphing calculator. I cannot manage to do this with my scientific calculator, but a graphing calculator will work. And since it is optional, and I'm hoping that a bunch of you will have this, I want to walk you through how to do it. So here's a table of information. These are temperatures taken from a city. These are the times, 8 a.m. to 6 in the evening, and these are the temperatures. And we would expect during the day, the temperatures would climb and then they would come back down. We would expect that. So what we're going to do is we're going to enter in this data between time and temperature in our calculator, and then we're going to ask our calculator to generate what quadratic equation would show or demonstrate would be the correct one for that type of relationship. Couldn't find the exact word, but I think you know what I mean. So in any case, you turn your calculator on and go to the Stat button, and under the X, list these down the X column. When you get to 2, change it to 24-hour clock, or it'll get really confusing. So make this a 14, this is 16, and this an 18, so that you're showing that the hours increase by 2, all right? And then during L2, your L2 list will just be these numbers, and they should be straight across from each other, just like they are in this table. So you enter in that data in L1 and L2 under Stat, under Edit. Okay, so you've done your editing. After you've done that, go back, hit the Stat button again, and this time select Calc, which means calculate. And when you see that calculate, you will see a whole sub-menu below that. We are looking for a quadratic. So if you go down, you should see something called quad reg. Okay, let me write that down so you know what I'm talking about. Quad reg, is it even capitalized? Yep, quad reg, which means quadratic regression. So you're telling it to give a quadratic equation for this. So you scroll down or you select the number next to quad reg, and hit enter. And then it asks you, do you want to use L1 for the X and L2 for the Y? Make sure that those are selected. So I have to change mine because mine's kind of messed up. And I want this to be L2. There we go. And now I go down to calculate and I hit enter. And it shows y equals ax squared plus bx plus c at the top. And then it says here's what your a should be, what your b should be, what your c should be. If you have it in your calculator, you might see this as well underneath. Okay, that's the coefficient. This tells you how close this is to actually being a quadratic. Does this data fit make a nice quadratic shape? The closer that number is to 1, then the more it does. And this is like 0.99999. Now, this saves you from doing it the other method. If you don't have a graphing calculator, you could treat these as 3 ordered pairs and do 3 equations, just like we did before. We did it before when one was 0, 0, which made it a lot easier. You're not going to get any 0, 0s, but it will still work. And you can use 3 equations and 3 variables, set up 3 equations, make y 52 when all your x's are 8, y is 64, etc., and then solve for your a, b, and c, and that will also work. But if you have a graphing calculator, woo, life is so much simpler. So practice doing that. You have the example in the book so you can see if your numbers kind of match theirs, and practice with it. If you have a hard time, then we can work on it together when we see each other in class. But this is how you use your quadratic regression in your graphing calculator. And I think that's it for this lesson. So I will see you guys next time.